Good afternoon. I am Ankit Acharya, working as an assistant professor in Hasmukh Goswami College of Engineering, and today my content is GTU question paper of December 2011. And we already seen this question paper up to question number 4A. So after that, question number 4B, we are starting from question number 4B. Okay, so let's see. Here is a question number 4B1. Find the basis for the row space and column space of the matrix A. And this is a 4 cross 4 matrix with first row is 1 4 5 4, second row is 2 9 8 2, third row is 2 9 9 7, and fourth row is -1 -4 -5 -4. So what we have to do here, first we want to find the basis for the row space and column space, right? And we know that one theorem, that first of all we convert this matrix, this 4 cross 4 matrix, into a row echelon form, right? So let's starting the process that we convert this matrix into a row echelon form. So we reduce the matrix A to echelon form as follows. Here is the matrix A with same as above. First row is 1 4 5 4, second row is 2 9 8 2, third row is 2 9 9 7, and fourth row is -1 -4 -5 -4. So here is the first process. We multiply first row with -2 and add into the second row. We multiply first row with -2 and add into the third row, and we multiply first row with 1 and add into the fourth row in this matrix, in this given matrix. So what happened now, you can see on the screen, first row as it is, right? Second row there is a change because we multiply first row with -2 and add into the second row. So second row become 2 -2 0, first element is 0, second element is 9 -8, that is 1, then 8 - 10, that is -2, and then 2 - 8, that is -6. So here is the elements, second row become 0 1 -2 -6. Okay, now we multiply first row with -2 and add into the third row also, right? So what happened in the third row, we multiply first row in this matrix, you can see on the screen, in this matrix we multiply first row with -2 and add into the third row. So third row become 2 -2 0, 9 -8 1, 9 -10, that is -1, and 7 -8, that is -1. So here is the third row, 0 1 -1 1, and then we multiply first row with 1 and add into the fourth row. So you can see the first row and the fourth row are same, just difference is only the sign, right? The first row is 1 4 5 4 and the fourth row is -1 -4 -5 -4. So when you multiply first row with 1 and add into the fourth row becomes 0 row, right? So that's why this fourth row become 0. Okay, so now what is our leading entry in the first column? 1 is the leading entry of the first column, and below that leading entry you can see on the screen all the elements are 0 now. Okay, now second row, consider second row. In second row what is our leading entry? 1. In second row second element, that is our leading entry. Below that leading entry we want to make 0 now. Okay, so what we have to do here, we multiply second row with -1 and add into the third row. That is our next process. So first and second row are as it is. First row is 1 4 5 4, second row is also as it is, 0 1 -2 -6. We multiply second row with -1 and add into the third row. So that's why the third row become 0 0 1 5. How it is? Because we multiply second row with -1 and add into the third row. So that's why the third row become 0 1 -1 0, -1 plus 2 1, and -1 plus 6, that is 5. Okay, so third row becomes 0 0 1 5, and fourth row is also as it is 0 0 0 0. Now you can see in the first column below that leading entry all the elements are 0. In the second column below the leading entry all the elements are 0. Now take third column, okay, and third row. In third row, what is our leading entry? 1 is our leading entry, and below that leading entry already we have a 0, right? So you can see this matrix is in row echelon form. Clearly this matrix is in row echelon form. And now the first 3 non-zero rows of the last matrix form A, basis for the row space of A. Here we use one important theorem, that for any matrix, if you want to find the basis for the row space and column space, what we have to do? We convert that matrix into a row echelon form, right? Now consider that row echelon form matrix. In that row echelon form matrix, take non-zero rows, right? Consider or take non-zero rows. That non-zero row vectors are exactly the basis vector for the given matrix A, right? And to find basis for the column space of the given matrix, consider the column in which we have leading entry. Okay, consider in row echelon form matrix, right? Whatever the given matrix, we convert that matrix into a row echelon form. Now in that row echelon form matrix, take all the column which have leading entry, and corresponding to that column we have to take in the given matrix column vector from the given matrix, right? Exactly we use that theorem here for the basis. To find for the basis for the row space, what we have to do? This is our row echelon form matrix. You can see on the screen, this is our row echelon form matrix, last matrix. Now in that row echelon form, in which row we have leading entry? First row we have leading entry, second row we have leading entry, and third row we have leading entry. Fourth row is 0 row. So that 3 row vectors, exactly the first, second and third rows, 1 4 5 4 0 1 minus 2 minus 6 and 0 0 1 5. These 3 row vectors are exactly the basis for the row space of A. Okay, that is I want to understand, that is I want to explain to you. Now next question, what is our basis for the column space? Now in that row echelon form matrix, in which column we have leading entry? You can see first column we have leading entry, second column we have leading entry, and third column we have leading entry. Fourth column does not have any leading entry, right? So corresponding to first column, second column and third column, we are taking first column, second column and third column from the given matrix, and that 3 column vector are exactly the basis for the column space of A. Okay, that I want to explain to you. So here is the answer. The first 3 non-zero rows of the last matrix form a basis for the row space of A. Thus basis of row space of A, that is equal to 1 4 5 4, the first row, 0 1 minus 2 minus 6, second row, and the third row 0 0 1 5, right? And now from the last matrix we observe that leading entries are in the columns 1 2 and 3 of A. So first column have leading entry, second column and third column have leading entry. So first, second and third column, that 3 columns we have leading entry. So corresponding to that 3 column, take first, second and third column from the given matrix A, right? So basis for column space of A is now 1 2 2 minus 1, that is, you can see first column of this given matrix A. Now next 4 9 9 minus 4, that is also second column from the given matrix, and then 5 8 9 minus 5, 5 8 9 minus 5. Okay, so because of in the row echelon form matrix we have first, second and third column we have leading entry, so that's why we use first, second and third column from the given matrix, and that is exactly the basis for the column space of A. Okay, so here is the complete this question, and this question asked in the 3 marks. I already written here that this question asked in the 3 marks in this question paper. So next question, question 4b2. Find a basis for the null space of A. Find a basis for the null space of A. 2 minus 1 minus 2, minus 4 2 4, and minus 8 4 8. This question is also asked in 3 marks. Now to find null space, first of all we have to solve this matrix, right? In this equation form, Ax is equal to 0. So A is a given matrix, x is a column vector x1 x2 x3, and 0 is also column vector 0 row, that is 0 column 0 0 0. So to find the null space of A, we solve this linear system of equation Ax is equal to 0. So 2 minus 1 minus 2, minus 4 2 4, minus 8 4 8 into x, that is x1 x2 x3, that is equal to 0 0 0. Okay, now to solve this linear system of equation, again we convert this matrix into a row echelon form. So that's why we multiply first row with 2 in this matrix and add into the second row, and we multiply first row with minus with 4 and add into the third row. So you can see second and third column are exactly the multiplication of the first column. You can see second column is second row is exactly the multiplication of the first row with minus 2, and third row is also multiplication of first row with minus 4. Okay, so whenever you multiply first row with 2 and add into the second row becomes 0, and whenever you multiply first row with 4 and add into the third row is also becomes 0. So only the first row we have non-zero row, second and third row becomes 0 row. So from that first row we will get this equation. This gives 2x1 minus x2 minus 2x3 is equal to 0. Now you should know that in row echelon form, whenever we solve the linear system of equation or this type of equations, we are considering, suppose how many vectors in which the column does not have leading entry, right? You can see the first column have leading entry 2, but second and third column does not have any leading entries. So second column is for x2 and third column is for x3. So that's why we suppose x2 is equal to k and x3 is equal to t here. Okay, so let x2 is equal to k and x3 is equal to t. So using that consideration, we will get x1 is equal to k plus t by 2 using this equation, because we have 2x1 minus x2 minus 2x3 is equal to 0. So that's why x1 is equal to k plus t by 2. So the solution is x is equal to x1 x2 x3, that is equal to 1 by 2 1 and 0, right? Coefficient of x1, coefficient of k in x1 x2 x3, coefficient of k in x1 x2 x3. So coefficient of k in x1, that is 1 by 2, coefficient of k in x2, that is 1, and coefficient of k in x3, that is 0. So that's why 1 by 2 1 0 into k, plus similarly coefficient of take coefficient of t in x1 x2 x3. So the coefficient of t in x1, that is 1 by 2. Okay, coefficient of t in x2, that is 0, and coefficient of t in x3, that is 1. So that is 1 by 2 0 1. Okay, so the basis for the null space of A is equal to 1 by 2 1 0 and 1 0 1. Okay, so here is a complete this question 4b2. Now next is question 4c. find the rank and nullity of the matrix. Here is a 3 cross 3 matrix, 1 minus 1 minus 1, 4 minus 3 minus 1, 3 minus 1 3, and this question asked in 2 marks. 1 minus 1 minus 1, 4 minus 3 minus 1, 3 minus 1 3. Okay, and we multiply. So again we convert this matrix into a row echelon form. So that's why we multiply first row with minus 4, add into the second row. So first row is as it is, 1 minus 1 minus 1. Second row become 4 minus 4 0, minus 3 plus 4 that is 1, minus 1 plus 4 that is 3. Now we multiply first row with minus 3, add into the third row. So third row become 3 minus 3 0, then minus 1 plus 3 that is 2, and then 3 plus 3 that is 6. Okay, so next matrix is 1 minus 1 minus 1, 0 1 3, 0 2 6. Now in first column we have leading entry 1, and below that leading entry we have all the elements are 0 now, right? In second row, what is our leading entry? 1. 1 is our leading entry. We want to make below that leading entry, we want to make 0. So the next process is we multiply second row with minus 2 and add into the third row. So first row and second row are as it is, 1 minus 1 minus 1, 0 1 3, and third row become 0 0 0. Now how we find rank? That is the next question. Whatever the matrix, if you want to find the rank of the given matrix, we convert that matrix into a row echelon form, and how many non-zero row in that row echelon form, that you have to see. Okay, how many non-zero rows, that is exactly the rank of the given matrix. So here the last matrix is in row echelon form for the given matrix. So in that matrix you can see we have only 2 non-zero rows out of 3. So that's why rank is equal to the number of non-zero rows in row echelon form, that is equal to 2. Okay, now another thing we have to find nullity.